Okay, now what we're going to do today is Newton's law of gravity. Okay, so as mentioned before, well, Newton discovered gravity, and he was quite good, and he derived the equation for it. The gravity for different planets and the gravity for different planets and the gravity at different height, different distance to the planet. So here is the equation. Okay. J is the universal gravitational constant, 6.67 times 10 power of minus 11, a really small number. Okay. Now it has a unit, but it doesn't. The units was put in there just to make everything mathematically correct. Okay. It doesn't have a meaning. So, yep. So big M is the mass of the bigger object. Normally in this case, um, it's a planet. So mass of the planet. So, so if you have two planets, it will be, well, we talk about this later. Okay. Now R will be the radius. Okay. The radius from the center of the planet. Okay. So we have gravity measured in newtons per kilogram. Okay. Or, well, from this is gravity. Okay. Now for the weight force, okay, will be the weight force will be mass times the gravity will be, okay, big M, small m, and r square here. Okay, it's measured in newtons. Okay, so the small m is the mass of small object, smaller objects. Okay, so if you have two planets, well, if you want to find the force of attraction between two planets, so they are basically planet 1, planet 2. Just, yep. Okay. So, yep, that's what Newton discovered. Now, from this equation, this very important part. Okay. What Newton, okay, I show you what mathematician derived. Okay, from this equation, if we read this equation, okay, now if, okay, on the same planet, okay, let's only consider uh, scenarios on the same planet. Okay, so on the same planet, the mass will be the same, will be unchanged. Okay, the gravitational constant, gravitational universal gravitational constant will be unchanged. It will be always this number in the universe. So what we can say is, if on the same planet, the gravity is inversely proportional to the radius square. Okay. Now, it means we can derive from this. It means when gravity increases, when the radius increases, the gravity decreases. Okay. When the gravity decreases, well, when the radius increases, when the radius decreases, the gravity increases. Okay. It means the closer you get to the center of the planet, the more gravity you have. Now, well, this only apply uh, in above the surface of the planet. Okay. It doesn't apply when you travel into the surface of planet. Okay. Okay. Now, the mathematicians, I show you what they were thinking about. Okay. Now, what's happening if this is the planet Earth? Okay. I'm standing on it. Okay. Now, I name, okay, the gravity I have will be J1. Okay. the radius here will be r1. Okay. Now, say if there's another person on the flying somewhere. Okay. Now, if I label his gravity at this position will be J2, and the radius will be R2. Okay. Using this equation, we can derive a ratio equation. Okay. You can write it, well, it will be in the exam, so write it down in your book. Okay. So the ratio between J1 and J2 will be, remember, inverse proportional. Okay. Will be R2 square, will be the ratio of R2 square and R1 square. Okay. So write down this equation in your cheat sheet. Okay, and make sure and mention that it only works on the same planet. Okay. So it will be different if one person is on Earth, the other one is on Mars.